So for the second part here, what we're going to be looking at is trying to create an actual distance for the race. So the big thing that we're going to be looking at here is we need to create a variable. In this case, we're going to call it distance. Again, be conscientious of your spelling and capitalization. And when we look at this, we want to actually put our distance in the bottom right-hand corner. So based off from this, you could change your readout by right-clicking. Again, there has been some issues with Scratch, which they've been contacted about for the right-click function. Try to get that readout of a different size. I can't quite get mine to work. So in this case, I'm just going to leave it as a small distance reading. So when we're looking at our distance reading, what we want to do is we want to actually program our distance. So when we're looking at this, what we want to do is we want to make sure that we set this distance to 0, which I've already done here. And based off from setting it to 0, we want to write a line of code. So based off from receiving a broadcast, so our broadcast in this case is going to be start. So when we receive the start command, we want something to take place. Well, what do we want to take place? Well, we want to repeat something until something else has taken place. So the thing that we are going to be focusing on repeating is we want to repeat the race until we have reached 100 meters. So in this case, we want to not use that box, but we want to actually use this one. So we're going to put that in there, and we want to actually have the variable, so distance. We want that variable of our distance to equal 100, which means that they've completed the race. Based off from our coding of that, what we need to do is we need to have our finish line move up here to move forward. So what we're going to do is we're going to actually add a control function. So we're going to actually wait until something. So in this case, we're going to wait until, and in this case, you're going to have to start with your left foot. You could put a or function in here saying left or right, but for simplicity reasons, we'll just say that we're going to start with our left foot. So what we want is we're looking for the pressed function. So looking at this, we want our control, I apologize. There we go, keys pressed. So we're looking at and wait until, and in this case, we're going to use our left arrow. So left and right are going to be our feet to move. And what we want to do is we want to change the backdrop by a size. So using the looks, we want to change this by size of 1. We're going to change size by 1 instead of 10, so we have that changed by a size of 1. And what we also want to do is we want to change our variable. So going back into our data, we want to change our distance by 1 as well. Okay, so now if we do this, we can click the green flag, again having your start. And as you click the left arrow, you can see that the finish line gets closer and closer and closer, appearing as if you're running back or running towards that of the finish line. Next thing that we want to do is just to fix this again, the y variable. Okay, so we want to make sure that our y isn't really running around. Again, you can see that there's kind of a slight offset with that as it moves towards the forefront. The other thing that we want to do too is we want to change the y positioning, in this case by -1.5. So while we do that, I want to change that by -1.5. Again, because of the proportionality as the things decide to move forward. So again, if you run this as a check, you can see now it's not rising up so much, but it's actually staying down with the surface of the road instead of floating up or appearing to go straight forward. So again, that's some things that you'd have to do in the calculation aspects of seeing where you want to end up to where you started. You could do the difference by a step change function, and then you would see that, okay, this is indeed staying on the surface of the road. The other thing that we want to do here is we want to do the same thing for the right arrow. So what you could do is just duplicate that line of code. When we do that line of code, we can actually throw that right in underneath the distance, and then instead of left arrow, we want the right arrow. So now we have the right arrow, and I'm going to keep everything actually the exact same. So we have the wait until, but the only piece actually here we need is just this long piece, this thing we can actually throw out here. So now if you were to run this code and you were to use your left and right arrow, you can see that there is indeed going to be a change in the movement. So as you're appearing to run, it appears that you're running closer and closer and closer to that of the finish line. Next thing that we can do is that we need to look at our finish line. So when we look at our finish line, one of the things that we want is we want it to actually appear to be broken. So as you appear to run through the finish line, you can see that I have two different already made for us. We have our normal and our broken. So the next thing that we want to do is that when we get to a certain distance, we want to actually switch the costume. So in this case, we're going to go to looks, we're going to switch costume to, and we're going to actually switch it to broken, and then we want to just put in the command to stop the race. So in this case, we're going to put stop all. So now, if you were to run this, you can see as you run towards the finish line, you can see now after you get to your 100 meters, you have now passed through the finish line, therefore making it to the finish line and through the stop ribbon. Last thing, if you want to play a sound at the end, you have to change your stop all function. So in here where it says stop all, you can actually change that to stop, and then in this case we would go stop all and block to stop other sprites, scripts in Sprite. So this would just stop all of the stuff things here. That means that the timer you'll create will stop counting, but the sound will still play. So that's going to be something that we're going to use later down the road when programming this game. Now that we've changed that, one other thing that we could use is a sound function, so we could play the sound of a cheer, so that when you cross the finish line, everybody starts cheering for you. The other thing is that we want to take away some of the cheating. So in this case, you know, if you're playing, if you were to hold down both of the arrows, you can run incredibly fast. One of the ways that we can eliminate that running of incredibly fast is by using another operator. So if, and then we're going to use the not function here. So we're actually going to add wait until not touching, and then we're going to also use, actually we can just use that on another command here. Actually, we're going to separate this into two lines of code. So we're actually going to take this line of code here, and we're going to use another wait until function. So wait until not touching, and then we're going to use that other key. Actually, we're going to use this probably twice here. So we'll actually duplicate this twice. So using our operator function again, not key. So wait until not. And then the other part that we're going to look at again is our sensing. So we're going to be looking at our key touching. So left key and right key. So left arrow and right arrow. By doing this, you will also eliminate that cheating function of just being able to hold down the keys. So that is another thing that we have to take into consideration when we add those. So when we run this function now, we should be able to see that you cannot hold down keys at the same time. You actually have to toggle out in between keys, seeing how fast you can indeed actually run. So taking a little bit of that out of there, which judges, if you're competing, would definitely like to see cleaning that game face up a little bit. So that completes step 2. A lot of coding in there and a lot of things to take into consideration, but all said and done, not too much code, but more thinking about the code that you're writing there.